Okay, now it's time to discuss how to implement this. And our first implementation is going to be really dead simple. We're just going to use a singly linked list. And it's going to be like it always was. So there's going to be a head that points to the first node, which is a container object that helps us to piece together pointers to other nodes. So I could arrange them perhaps in this order, although the order is arbitrary. And the only difference is, okay, the node now encapsulates not only just one object, but two. You could think of the object that we stored before as a key, but now we're also storing the value along with it. But nothing else really changes at all. So we still have a head that points to the beginning. Each node has a next arrow, and then the last node in the list points to null, right? And that's really it. Okay, so we already know how to implement a linked list, so this is not really going to be too much more work. But let's go through some of it anyway. All right, so there we go. So each node stores a key and a value. So if I'm going to go look how to make this with classes, here is the node class. And so in addition to having just one object, we have two objects now, the key and the value. And then we have a pointer to the next object. Now I sneaked a couple new things in here, though, that I hadn't done before. One of them is that I'm actually defining a template that uses two classes now instead of one. And so I have to give each of those a different letter, a different name that I will eventually plug something into, because they may be different types, right? The type of the key does not have to be the same type as the value. Okay, but we still have this next pointer, which starts off as null, and then the constructor is going to take the key and the value and store those. The other thing I did that's a little bit different is I made this actually something called a friend class of linked map. So remember, you probably remember this whole time we've been making everything public. We've been making, with the linked list and the doubly linked list, we always had the next and the object we were encapsulating be public so that we could access them very easily from outside of the class, from within the linked list. But really a better programming practice from an information hiding standpoint is to actually have the key and the value be private. We really shouldn't be able to change them outside of the class willy-nilly, but we will allow one class, linked map, which is called a friend class, we will allow that one class to access private variables, and this is the way we do it. And don't ask me why we have to use different letters for the templates here. but we do. Otherwise, it just works out. Okay. So again, we're doing basically the same thing we did before, but now we have two objects instead of one. We have the key and the value, and each one of them has a different template. And I'm also making this a friend class of linked map, so that linked map can access these private variables. Linked map is the only class outside of the node class that should ever be able to access those variables there. Okay, so that's one thing. Now otherwise, okay, so I already implemented remove first. That's the whole thing we do where we, take out what's at the beginning. Actually, should be a little careful here and make sure that that the beginning is not null. So I'll do that. And so, yeah, maybe I'll just declare ret up here by itself, and then if the head happens to not be null, then I will take what's at the beginning. I will store a reference to what the old head was, and then I will advance the head on to the next thing, and then I will delete the old head. So we've seen this before. But yeah, I want to be careful not to dereference a null pointer there. Okay, and the constructor for the map looks just like the constructor for a linked list. It's dead simple. All you got to do is set the head to be null. That's what it means for the linked list to be empty. And then for the destructor, we're just going to keep removing the first element as long as there is still something there. Okay, so far it looks exactly like the linked list. So what's different? Well, okay, so we don't call, so there's a different naming convention. It's not exactly the naming convention used by C++, but it is the naming convention used by other languages like Java. We don't say add, we say put instead, to differentiate that from just like adding a single thing. So when we put in a key value pair, We're not just putting in one thing. We're actually creating a node with both the key and the value encapsulated. But otherwise, I mean, since this is an implementation of a linked list, you know, I'm going to do the same kind of thing where I make a new node. I put the information in there. So let's say it was, I don't know, Eric. And his favorite classes to teach are Math 111. And I don't remember what differential equations is. I'll make up a number, 340. And so we're going to make that new node. It starts off with a next pointer that's null. But of course what we have to do is set the next pointer to be what the head currently points to, as we know. And then we can update the head to point to this, right? So let's do that little dance in code. So I made this new node, that's great. Now what I need to do is make this the next pointer, which I can access because I'm a friend of the node class, so I can access that private variable next directly. I'll make that equal to what's currently the head. And then finally, I'll make the head be this new node. Now, I'm being a little bit lazy here because technically, if a key already exists, most map implementations will actually, you know, we're not supposed to duplicate the key, right? We're never supposed to, we should be checking to make sure this key is not already there. And if it's already there, we'll update the value. But I'm just going to be a little bit lazy here and not do that for now. Just so it's a little bit more like the linked list that we already had. Okay, now let me check to make sure that this thing compiles. Good. So far so good. It seems like at least syntactically we got through put. Let's also do get. So get, well, we're going to have to, so this is, it's again very similar to how it was in the linked list. We've got to start, we have to start at the head. That's the only place that we have to start off at. And we have to have a cursor that starts off there to whatever the head points to. And yeah, maybe I'll call it cursor. And as long as that cursor is not null, I can go ahead and check what's there. And if the key that I'm looking for is equal to the key at that cursor, then that's great. I can return the value associated to it. That's what the get is supposed to do. It's supposed to look up the key. It's like that, or, you know, what C++ STL did with the array access. And so yeah, we can do that. And then so, but it's possible that nothing was there. So we'll loop along until we either find the key we're looking for until we get to null. So I will make that cursor. So I will say, all right, let's make the cursor. It's a node pointer, templated in this way. It starts off pointing to the beginning, and so I'll say, okay, while the head is not equal to null, or sorry, don't want to do that. That's a common mistake. While the cursor is not equal to null, so while I'm still actually pointing to a real thing that's in the list, I want to check to see if the cursor's key is equal to the key we're looking for. In that case, I will set the return to be equal to the value at the location that the cursor points to. And then I will make sure, so I don't have an infinite loop, I will move the cursor along. So I'll say cursor equals cursor next. That's all there is to it. Okay, so let's go back to the main and see if we can use this data structure that we just made and fill up with a similar example to what we did before. So I'll just copy and paste this, and I will. So instead of insert and all this pair stuff, it's just. Well, actually, first let's make sure we use our own data structure here. So we called this, you know, the linked map. That was our version here. And instead of insert, the method was called put, and then it just directly took the key and the value as parameters. And so we'll just update all of that and see if we can compile it. Let's first try that. It's a little bigger here. And let's compile. Oh, it says it has no method insert. I got to update this in all three places here. It's called put. That's what we call it, put. Key is the first parameter. The value is the second parameter. Good, so that worked. And let's just see if we can try out. So I didn't make the contains key method yet to actually see if things are in there. So here I did something like a contains key with the STL library. This is the way that you would do it to see if a key was actually there before you looked it up. This is like the get method. But let me just do the get method and see if I can output something. So the value associated to Chris is this list here. So if I were to say cout favnums dot get Chris, and then that should return this vector. So if I look at index 0, that should give me 174. So let's see if it does that. So let's run it. And it sure does. So it's one of the most complicated ways to date that we've had of printing the number 174. But no, it's really not that bad. So again, the only thing we did was we added something extra to the node class, the value, and we were, I threw another extra thing in here with the friend classes, but otherwise, the implementation of the destructor and the implementation of put, which is just like add, and then the implementation of get, which is just like we did before for seeing if something was there. That's all very standard. Okay, so I'm going to have you just do an exercise real quick to see if you can implement contains key. But then I'll explain a much better data structure for doing this.